Let's discuss the question number linked to question number 54 and 55. This is from test 4 solid mechanics, strength of materials basically. Okay, so a bell crank mechanism is given. Let me draw it. Okay, and a hinge is there, B. So at end C you are applying 100 newtons and those dimensions are given 2 meters, and to balance the force P is applied, which is unknown. In fact, that is what is asked in B. Now at B, at hinge B, there is a pin which is in double shear. Okay, so and the shear stress is given, and we are asked to design the appropriate diameter of the pin. Okay, so first, so for the 54th bit, let's first find out P. So for this, what I'll do is I'll just draw the free body diagram of this bell crank, where the reaction forces of the hinge are By and Bx, and this which is P, and this is 100 newtons. This is my 2 meters and this is my 1 meter. Okay, so now because this is in equilibrium, the bell crank is in equilibrium, so I can basically use summation of sigma forces 0, summation of sigma forces in y direction 0, and sigma moment about any point is 0. Okay, so what I'll do is I'll just use the third equation, that is sigma moment about any point. I am choosing the B point because this will eliminate Bx and Vy. So in that way, let's put the clockwise as positive. The clockwise moments are positive. So 100 into 2 will produce a clockwise moment, which is positive, and P will produce the anti-clockwise moment, P into 1. So there is no other forces which produces moment about B, so this has to be 0. So P is 200 newtons. So the answer for this is A for the 54th bit. Now for the 55th bit, what we need to do is we need to find out the total force that is coming on the pin, and then we can see the state of shear for the pin and what happens for the pin. So here, if you look at the side B, as he has said that it's in a double shear, so pin B is like this, and the total load that is acting is somewhere like this, which is the summation of Bh square plus By square. So the total load is this. Let me call this as F is root over Bh square. So that total load F gets sheared in these two ways. So I need to basically first find out F. So for that I need to find out Bh and Vy. So I can just use sigma Fx0. So let me call this as X and this as Y. So sigma Fx0, taking the forces in the X direction, positive X direction. So Bx minus P is 0. Bx is equal to 200 newtons. And now sigma Fy, taking forces in upward Y direction as positive, along positive direction as putting the forces along positive Y as plus. So that will be Vy, and then 100 is downward, so it is minus, is equal to 0, and Vy is equal to 100. So the total force that comes on the pin is basically the resultant of this, because they are collinear. And the resultant will be root over Bh square, as it has only two components. So root over 200 square plus root over plus 100 square. So that is nothing but 100 root 5. Let's keep it like that. And now let's come back to this figure. So as it is in double shear, so the shear force will be basically F by 2, and the shear stress is basically F by 2, which is the shear load into the area of cross section, assuming that pin is circular, so it is pi by 4 d square. And now the shear stress of the pin is given as, the allowable shear stress is given as the 60 MPa. So I can just use this as 60 MPa, and force I have found out as 100 root 15 by 2 into pi by 4 d square is equal to 60. So what is remaining is to calculate d. D comes out to be 1.54 mm. So the answer is C. Thank you.